Welcome to the webinar today. We're going to talk about the tech in fintech, the data and algorithms that power the industry. My name is Elise Breda. I lead the growth strategy team here, and I'll also be joined by Colin Ristig, who leads the product management team. For those of you who aren't familiar with Yhat yet, I'll sort of start backwards, right to left. Our flagship product is ScienceOps. It is a platform that allows data scientists, risk analysts, anyone building in R or Python to deploy their machine learning or data science projects into production apps. And then we just announced a beta of Bandit. That's a centralized data hub or centralized hub for data scientists. If you're interested in that, check out our website and you can get an invite to the beta. And then our IDE Python, or our Python IDE Rodeo, that's free. If you're doing data science in Python, be sure to check that out. Like I mentioned, today we're talking about fintech. Hopefully you knew that. Hopefully that's why you're here. These are just a few of our fintech customers, and quite a few of us at the company also have experience working in fintech. Colin, who will be speaking in just a moment, worked at PayJunction, and our two co-founders actually came from OnDeck. So before we dive in, an agenda. Just as a reminder, the webinar should take about 30 minutes. We will save 5 or 10 at the end for Q&A. And if you look at the bottom left of your screen, there is a moderated chat, so feel free to send those questions over, and we'll address those all at the end. We also will be sending the recording and slides out. I tend to get that question often. Anyway, without further ado, what is fintech? What are the leaders doing differently? So it's this kind of buzzword of an industry that's really grown in the past 5 to 10 years. But why have some companies been more successful than others? And if we're able to pinpoint these success sort of criteria or factors, then why isn't everyone doing it? So first, what is fintech? Fintech isn't actually so much a completely new industry as a sort of combination of two things. So it's finance, traditional banks, but embedding and using technology to automate a lot of the tasks associated with the finance industry. So whether that's checking, savings, payments, lending, it's tech companies coming in and eating away at the business from big banks and doing a wide variety of financial transactions faster in a lot of new markets. So we'll get more specific in a moment. Here are 6 of the sort of sectors or pillars of finance and consequently fintech. Then here are a few of the companies who have come in, the fintech companies, and who have sort of revolutionized these sectors, whether that's an app on your phone like Mint used for financial literacy, or it's a consumer and small business lending company like OnDeck. Regardless, the sort of underlying theme is automating tasks to offer these financial products both faster and cheaper, so the companies are able to get greater margins and exist either pushing out those traditional financial players or existing with them. And we'll talk about a little bit of both. So for today's purpose, because we can't cover all 6 of those sectors, we're going to be looking at consumer and small business lending. One, because we think that the lessons that we'll talk about kind of apply broadly to the rest of the sectors. Also because it's one of the largest, and there's also clear leaders. So we want to talk about what, like it's in the title, what data and algorithms set leaders apart. So we're able to do that, draw those distinctions pretty clearly in this. So some of the names you might be familiar with: SoFi, Lending Club, Avant, Prosper, OnDeck. A lot of folks are entering this space quickly, but there are kind of 5 or 6 large players. So one of the really interesting things about small business lending is that the underlying product that these fintech companies are offering is actually the same. So there could be a different interest rate attached, but ultimately every company is offering capital, whether it's Wells Fargo, SoFi, OnDeck. You may receive it through a direct deposit, or you may actually have to go into the bank and show your face, but what you're getting at the end of the day is the same. And within fintech, not necessarily banks to fintech or traditional finance to fintech, but within fintech, even the methods for deploying that capital look very similar. So here we've highlighted 5 screenshots. I think there's SoFi, Avant, Lending Club. The names don't really matter so much as the fact that if you close your eyes and point your finger at one, you're just as likely to pick, or it won't be obvious whose site you're looking at. So each it's a pretty simple web form, JavaScript or PHP, asking for your name, address, not asking actually for a ton of data, and we'll talk about how they gather more of that on the back end. But you're going to get approved or denied in seconds or minutes. So the capital you're receiving is the same, and the way it's being offered is actually the same. So that kind of leads us to the question, what are leaders doing differently? If what I'm receiving is the same and the means of receiving it looks the same, why is any company going to pull ahead? And the answer to that is that successful fintech companies are operating in new markets, which I'll talk about as compared to traditional finance, and they're making good lending decisions. So one of the central aspects of fintech versus finance, and what's really particularly innovative about it, is that fintech companies are reaching previously underserved populations. So if we think about small business lending, that may be mom and pop stores who the proprietors didn't have a previous credit file. It could be different geographic locations, so developing countries where we've seen fintech really sprout up, and we'll talk about some of the logistics behind that. But successful fintech companies are able to operate in new places, and despite that novelty, they're able to make good lending decisions, which good is kind of a subjective term, and what I mean is that they're able to lend capital to more people who will be able to repay it, and they're able to find defaulting loans or extend defaulting loans less. So kind of the crux of that, and what we're going to take the rest of the 30 minutes to talk about, is the algorithms that these fintech companies are using to make data-driven decisions. And that sounds very buzzwordy, but to pull it apart, first the data. So many of you, if you're in the fintech sector or even just reading about it, will be familiar with the term alternative data. And that's when typically fintech, some finance players are doing it as well, but companies are using alternative data. So that could be, we have a customer who uses internet history because they found that that's correlated to ability to repay. It can be phone payment history, your social network connections, how you're embedded in that. It's very creative uses of data, a lot of the times through publicly available APIs, which many of you might be familiar with. And then it's using that data in creatively written algorithms. So an algorithm is a process or a set of rules, typically written by data scientists or risk analysts, and executed as a program or model automatically. So that's different than typical underwriting done by a human, which also had logic to it and had if this, then that, and maybe some kind of decision tree. But it's both performed automatically and it can become more intelligent. So it can be retrained on fresh data rather than this kind of static set of rules that a person or even person plus computer may have followed in typical finance. So to get more specific and really start to dig into the details, we're going to talk about 5 different areas where this new alternative data and creative algorithms are being applied by fintech companies. So I'll cover the 2 on the left, marketing and personalization, and then I'm going to hand it off to Colin, who will talk about really the guts of fintech companies' decisions, which is credit decisions, risk-based pricing, and fraud detection. So the first task, if you were to open a fintech company today, small business lending or otherwise, but we'll keep with that analogy, first thing you need to do is get customers. So like I mentioned, fintech has specifically gone largely after underserved populations. And one of the tools or one of the ways that fintech companies are using data in marketing is in segmentation. So as an example, at On Deck, our co-founders were working on using alternative data, and we won't get into their specific data sources, but they were sorting existing leads through clustering algorithms. So that could be k-means. There's a variety of different clustering algorithms, but sorting those leads into sort of buckets, coming up with who ideal customer profiles were, and then the next step, which is targeting them. So targeting is once you've come up with who you should be going after, it's how you actually reach out to, advertise to, market to those segments or the individuals that the segments are composed of. So as an example, in real life, one of our customers is using machine learning, and their team is using random forest algorithms at the moment to target their ideal users or their ideal loan applicants. And they actually purchase the leads that fit with their profile from a third-party vendor. So they've created their segments using algorithms, and they actually target them in an automated way. So you can see already how the process is becoming a lot faster and a lot more sort of rigorous by automating it and setting these algorithms to it, which can be retrained and continue to be refined. And then finally, just to bring it full circle, there is the attribution. So a lot of companies will centralize this, collect this data in Google Analytics, or some will build their own systems from scratch, but that's using things like UTM sources, Facebook pixels, wherever you're advertising, it's collecting the data on the back end for who actually converted into a paying customer, and then in the case of loans, whether they were successful. So did they make their payments on time? Did they end up defaulting? And then using that information in the future. So second thing, you've reached out to or marketed to folks, and let's say they actually come to your site now. So here on the screen, we have an example from Capital One, who probably most or all of you are familiar with, and then your cookie and browser, or your cookie history on the left-hand side of that. So what we're showing here is personalization. It's been a huge push with all of this user data to really personalize people's experiences. I had a former colleague who said that people know whether they're at home on a website in the first few seconds, and that's equally true in fintech with all of these new players popping up. There's no shortage of places that people can go to get capital. So on Capital One site, they use this cookie history as well as some other data like geographic or things that are purchased from a third-party vendor to decide which of their products in what's above the fold to show. So for me, as a young female living in a city, it's probably not very useful to get a home mortgage loan, but I happen to get a car one, which is more applicable to my personal situation. And then one other thing that people are personalizing and using algorithms to automate is how the site appears or how the app appears to new versus returning users. So if you have someone who has already begun their loan application, the site should recognize that intelligently, collect data, and then possibly even collect and integrate any changes, or let's say they've gotten denied before, perhaps they should be offered a higher interest rate to account for that. So it's using the data that you've previously collected as well as any changes to update and personalize the website. So with that, I'm going to hand it off to Colin.
Cool. Thanks, Elise. So far we've talked about the kind of above board optimizations that fintech companies can do, addressing the question of how do we get people to arrive at our site and even, one, know we exist, but two, take interest in the financial products we offer. Once that's happened, we get kind of into the more traditional finance categories of how do we decide whether to deploy capital to this individual, and at what rates do we do? And if so, what are the sort of pieces of data that we're going to take to base these decisions on? So the first of this kind of subset of algorithms that we'll talk about is fraud detection. So this is kind of a classic example of any sort of issuance of capital is going to be tied to fraud. People are obviously going to want to take advantage of a company who's maybe issuing capital online. So how do we begin to detect whether someone is who they say they are or not. Um, from a high level, fraud obviously deals with illegal or malicious activity, but on a more kind of getting more specific, we can kind of break it down into two categories. There's true fraud, which is, I can be masquerading as someone whose identity I've stolen, or pretending to be a business owner of one that I don't actually own, which is, truly malicious. That can extend into different categories. So money laundering, for example, was an issue that a lot of the peer-to-peer finance companies had to deal with, because it was a great way for people who were, working in organized crime or doing illicit activities to transfer money really easily through that platform. So there's that type of fraud. But then there's also kind of just misrepresentation, which is perhaps less malicious, but important to capture in a risk algorithm. An example of that could be, I may be a 19-year-old college student who wants to get a loan, and if I put on my application that I make $200,000 a year, 90% of my application may in fact be representative of who I am, but that one facet that is, misrepresenting the truth is really important to factor into a credit decision. So building a model that can incorporate these different types of information is really critical. One thing that's really unique to Fintech is, and as the name kind of implies, a lot of the application process is entirely electronic, which is, if you think as opposed to traditional banks, where you're walking in the door, you have a whole host of information that is not part of a traditional kind of finance loan application. I can look at IP address ranges, the time of day someone's accessing our website, what sort of browser or operating system they're using, whether they're mobile or desktop. Really interesting on that last point is a lot of the fintech companies that are trying to access users in developing countries have found that the phone orientation actually is a really strong indicator of someone who is a fraudster or not. Kind of tying this all together, while fintech has the ability to issue loans at a faster rate, if you talk to anyone who's received a loan from any of the companies we've mentioned previously, the one thing that they'll say is that I chose to go with company XYZ because the process was fastest. They were able to deploy the capital and get it in my bank account the fastest. So that's great for the user, but that also is kind of the core of what these fintech companies expose themselves to on like a risk and fraud side. The next kind of major subset of algorithms that fintech companies use is obviously credit decisioning. So we think about FICO based upon a user's characteristics. What's their credit riskiness? Are they fully employed? Do they own a home? What's their outstanding credit balance? And so fintech has done a really interesting job across the board of taking advantage of alternative data sources. That's kind of a theme you'll have noticed across this whole presentation. Many will use credit bureau data to kind of act as the backbone of their algorithms, but then over time they can begin to incorporate additional information. So Elise mentioned like whether you have interest in a car loan, like what's your driving record look like? Are you a risky candidate because you've gotten in more car accidents? A whole host of other things like that. Ultimately, though, what many of these companies have found is that while FICO is from the start a strong backbone to build these algorithms on, they can often build models that, if they can incorporate enough alternative data, can prove to be a better predictor of creditworthiness than FICO itself. And what that means, not only in terms of, obviously the ability to predict creditworthiness is important, but they can avoid paying credit bureaus for these reports in their entirety and cut the cost of deploying the capital down significantly by having enough data to build models on and effectively create scorecards themselves. Proxies for risk is basically another way to say what we've just described. Looking at characteristics of people that may be indicators of creditworthiness or not. Where this is really important is small businesses. Most people who open small businesses haven't done it a ton of times, so there's a really, really limited amount of history to go on. So you have to look at other facets of maybe their personal credit history, other things that they've done to kind of bootstrap your models in the short term. Asking questions of like, how do we build a credit model for someone who hasn't used a traditional bank before? This is especially common in developing countries where traditional banking systems don't exist. So how do we issue loans to people in Mexico if they don't actually have a bank account? A lot of companies have found that as a proxy for risk, phone payments. So do I pay my phone bill on time? That is a really, really strong indicator of creditworthiness. Ultimately, though, with all of this data and imputation methods, we can build stronger and stronger models with less and less data. So imagine we arrive at a lender's website, and maybe English is not my first language, and I don't understand some of the fields that need to be filled out. If our imputation models for those fields are good enough, we can make really, really good predictions without all of the data that would typically be required for a loan applicant. So this cuts down the barrier of entry for people who are applying for new lines of credit. And then the last category we have is kind of, this is a little bit more macro, but how do we determine people's willingness to pay for our product? So for one, we need to offer a competitive interest rate. But two, we also need to make sure that on the whole, maybe we have hundreds of people who our credit algorithm deems as worthy enough for credit and not risky enough. But across a portfolio of, say, 100,000 loan applicants, we need some sort of reasonable distribution at which people will pay us back. So most of our customers that we work with and companies I've worked with in the past have an optimization process that is done in batch that runs every single night or once a week and takes in all the payments that existing customers have made and tries to basically run an optimization process to see, given our current exposure to risk, how do we need to adjust today's credit policies and the interest rates that we're offering new applicants for loans in order to adjust our portfolio risk as opposed to just focusing on an individual. Things like expected loss come to mind. What's really interesting about this subset of category or subset of models is you can use some really cutting edge optimization processes to really both model but also simulate different sorts of scenarios. If, say, for example, we enter an economic recession, how does that impact our portfolio given its state today? So there's a lot of interesting things that people can develop on top of these. Keras is actually one library. It's a deep learning library that several people we work with have begun to look into for running these sort of optimizations and looking at loss curves over time. So we've mapped out 5 areas where algorithms can be used in lending to make processes more efficient and reach out to new markets. So why isn't everyone doing it? Why don't we all run a little lending website on the side and issue capital to small businesses? And the truth is, it's really quite complicated. If we think about just within the scope of what we've outlined today, we have 5 different categories of models we can build. Each model is going to have specific data sources that are often disparate and be potentially written in different languages that utilize different libraries and tools. Ultimately, even if I overcome, the difficulty in building a statistical model in itself, that model ultimately has to end up embedded in a production application, or it serves absolutely no business, or it doesn't serve the business any value if it just exists on my laptop. Um, the challenge with that is implementing complex machine learning algorithms that are maybe statistically complex, but also difficult to implement from the engineering standpoint, can be really difficult, both technically speaking, but also from an organization's perspective. Um, all of that leads to the implementation process taking a really long time. So if I, as a data scientist, hand off my new credit decisioning model to our engineering team, and it takes them 6 months to update the algorithm that's being used on the website, that model is probably decayed and lost a lot of its kind of robustness and value over that course of time. On top of that, most of the models we've discussed today are intertwined and feed back into each other. So if we think about our fraud detection model should obviously have some impact on our credit decision, as well as our risk-based pricing. They're all very correlated and integrated problems. The same thing goes with marketing and personalization. We should be targeting the people who are completing the applications on our website and also driving personalization for those that are most likely to complete. Thinking about this even further, all of the lending companies we've talked about so far today have mobile applications, CRM systems, web apps, and many often also many also provide a white label integration for other websites to offer lending services at the point of checkout. All of those different things require integrations into the models that we've just talked about. And going further, thinking about the legal ramifications of deploying capital internationally or across state lines, every single place that you operate has restrictions and regulations around how credit decisions can be made, and all of your models need to reflect those decisions. Currency is also a big issue for companies who are working internationally. If we think about PayPal, they operate in 202 different countries with over 25 different currencies. So all of their models have to be customized for these different use cases. And just thinking about this even further, say we were to build a system that we built 500 different machine learning algorithms to handle all of these different use cases. Those machine learning algorithms also need to be updated consistently. So we can't constantly be going over to our engineering team once a week and saying, hey, I built a new model, let's get this integrated into our 15 different applications. These models also have to support potentially super high throughput if you're doing point of sale checkout in particular. And we also have to, as an organization, have insight into how these models are performing, both in the sense of are we issuing credit? Are we deploying our capital well enough? But two is our uptime for these applications being impacted at all by the complexity of these models? So in short, it's a fairly daunting task, and I think you could make the argument that the complexity is unmanageable to the point that we see very few companies emerging as leaders due to the nature of how hard this problem is. And that problem is exactly where ScienceOps, the kind of Yhat's flagship product, is designed to do. So we allow data science teams, credit risk analysts, portfolio analysts, quants, etc., to build production-ready models and deploy them into an application that can be integrated into any web app or mobile app via a standard REST API. So I can use, with ScienceOps, the greatest and latest in open source technologies, so things like Keras, MXNet, and take all of that logic that I'm capable at building as a credit analyst and deploy it into ScienceOps where I can get a dedicated REST API endpoint that can be integrated into dozens of applications, regardless of the language. So if we think about companies that use Salesforce and have a PHP website and a mobile app written in C#, all those applications can access this same model because of the nature of a REST API. Again, because of that, we can update our credit models without involving IT. I can push changes to my credit scoring model or my fraud detection algorithm relatively simply without involving IT. And in the real-time sense, we can also monitor all of our models, look at how the data going into our models and coming out, the predictions we're creating are changing over time, ensure that the logging and recording of all of that is compliant, catch any errors in our model. So if we're not checking for a specific value that maybe the credit bureau is sending us, we'll get insight into that. And ultimately provide a system of record for all predictive models that are deployed and integrated into production systems. So unfortunately, we don't have time to demo ScienceOps for you all today, but if any of you are interested, we'd love to sit with you and show you all the cool tools we've built and go over this all in more detail.
All right, thanks, Colin. At this point, I think we're a minute over, so